So in this video, we're going to check some questions on set theory. I have explained set theory in the previously video. Now let's check it out. We say, if the universal set equals to x such that 0 less than x and x less than or equals to 10, set A equals x such that 3 is less than x or equals to 3 is less than or equals to x and x is less than or equals to 7. Then B, set B is x such that 10 is greater than or equals to x and x is greater than or equals to 5. Now before we solve anything here, we have to find what the elements in the universal set A and set B. Now universal set, we say that what universal set is what x such that x is greater than 0 if I reverse it. Remember, under inequalities, if I say 0 less than x, that means I can write this thing as what? X greater than 0. Now, if x is greater than 0, that means x is 1, 2, 3, 4, 5, 6 to infinity. But I have an origin. I have where I should stop. I have a boundary. And what's the boundary? I said x less than or equals to 10. That means x is either less than 10, yes, or equal to 10. That means it does not pass 10. The maximum number of x is 10. 6, 7, 8, 9, then the last number 10. Don't forget your curly bracket. Now the next one is set A. What is set A? We say set A is what? X such that 3 less than or equals to x. If you rewrite this thing, that would be what? X greater than or equals to 3, which means x is starting with 3 and above. That's 3, 4, 5. Then I'll still keep going until I get to this place. I said x is less than or equals to 7. X is less than or equals to 7. That means the origin, the boundary of x is what? Is 7. That's 5, 6, and the last number 7. I know you might be wondering that, yeah, I said x greater than 0 and I did not add 0 in the universal set. Yes, I can't add it because they said x is more than 0. They did not say x is greater than or equals to 0. So I'm not starting with 0. I'm starting with a number greater than 0. So for set B, say what is, let's say x such that 10 greater than or equals to x. That means 10 greater than or equals to x. If I rewrite it under the law of inequalities, we are going to say that what from here, please let's come here, so that x is what greater than, this is greater than, it's changed to what less than or equals to 10. That means, oh, I see something here. X is what? X wants to be decreasing. So it's starting with 10, 9, 8 to what? I don't know. Let's check the second part. X is greater than or equals to 5, which means the origin of x is what? Starting with 10. Since it's starting from up, then decrease up to what? Up to 5. As 8, 7, 6, and the last number is 5. Now, the questions that we have here might ask you, find A intercept B. That's question 1. I have it written here. It said find A intercept B. That's very simple. A intercept B are the what? Remember, I told you earlier that intercept simply means what? What is common between two or more sets. Now, what is common between set A and set B? Now, the elements that are common in set A and set B will be, we have 3 here, there's not 3 here, starting with 5. So we have 5 here, there's 5 here. So the first one is 5. The next one is 6, we have 6. The next one is 7, and we have 7. Then we are done. 5, 6, 7. Question 2 is find A union B. Now, A union B was joining of set A and set B. So that was 3. Let's first write this set A down. 3, 4, 5, 6, 7. Now, let's move to set B now. 5, I have written it already. 6, I've written it. 7, I've written it. 8, I've not written it. So I'm going to write it now. 9, then the last one, 10. The next one is find A complement intercept B. What is A complement? I told us in the last video that what A complement are the elements in the universal set, but not in a particular set. So A complement will be what? The elements in the universal set here, but not in A. So what are the elements in this place, but not in A? We say we have 1, we have 2, because there's no 2 here. There is 3, so I'm not going to write it. 4 is there, I'm not going to write it. 5 is there, 6 is there, 7 is there, 8 is not there, 9 is not there, and 10 is not there. So that's 8, 9, 10. Intercept B. What are the elements of B? It is written already. You say 10, 9, 8, 7, 6, 5. Now, what is common between these two elements? Between these two sets, we say what? 1 is here, 1 is not here. 2 is here, 2 is not here. 3 is here. Oh, 3 is not here. 8 is here, and 8 is here. So 8 is there. That's the first one. Next one is 9. 9 is there. What's the next one? 10 and 10. I think that's what is common between A, in complement of A and B. So let's check more questions. Now, if this same question is now asking us that we should find another value again, let's say our next question, this is number 2 question now, still the same question that I've explained earlier. Now, let's say ask us to find subset of A intercept complement of B. That will be equals to, oh, never mind, I made a mistake here. A intercepts complement of B. That's very easy. We just come here and bring set A. And what are the sets? What are the elements in A? We have 3, 4, 5, 6, 7. We have it here. Now, intercept complement of B. Complement of B will be elements in another set here, but not in B. And that's what. I'm waiting for you to list it for me. Oh, yeah, list it now. So you have 1, thank you. 2, 3, we have 4, and I think that's all. Because after 5, we have 5 here, 6, 7, 8, 9, 10. So I'm going to stop in 4. Now, what is common between this and this? And that's 1 is, okay, 3 is here, 3 is here, good. 4 is here, 4 is here, good. 5 is here, 5 is not here, 6 is not here, 7 is not here. So the element that is common between A and complement of B is what? 3 and 4 only. Now, what if they now ask us to find A intercept B, then the power? That will be what? 2 raised to power n. Don't forget the formula. And that's what? 2 raised to power 1, 2, 2. And that's 4. What if they ask us to find the subset of A intercept B complement? That will be what? Empty set, thank you. Set 3, elements 3, thank you. Element 4, and the last one, elements 3 and 4. That's 1, 2, 3, 4, which is the same thing as this 4. So I think you are good with sets. You should be able to solve more questions on sets. But that comes to my mind. What if they ask you that you should find set A minus set B? This comes to my instinct now. I'm so sorry. I did not explain this in the last video. It's very simple actually. What I mean is that what are the sets I can find in A but not in B? That was very easy. It's just like checking the complement of between A and B. So the element I can find here, the one I can find, I'm going to cancel it out. A and B, what do they have in common? That's the first thing. A and B has, oh, A has 3. This one does not have 3. So I'm going to have 3. It has 4. It doesn't have 4. It has 5. It has 5. So that means 5 and 5 we cancel out. It has 6. 6 minus 6 we cancel out. 7, it doesn't have 7. And the last number, 7. Final answer. B minus A. Note, B minus A is not the same thing as A minus B. B minus A now will be what? Elements I can find in B, but not in A. Now let's check. We have 5. There is 5. We have 6. There is 6. We have 7. There is 7. We have 8. There is no 8. So 8. We have 9. There is no 9. We have 10. And there is no 10. So 8, 9, 10. B minus A is 8, 9, 10. A minus B is 3, 4, 7. What if they now ask to find A minus B complement? That's very easy. Check something. We have said A minus B is 3, 4, 7. That means A minus B complement is what? Coming to this universal set now, I'm going to write everything down, but without what? 3, 4, 7. And that's what? 1, 2, 3 is there, I will not write it. 4 is there, I will not write it. 5, 6, 7 is there, I will not write it. 8, 9, and 10. Now, go and try B minus A complement. I'm waiting for you. Now, you can pause the video as you are doing that. So we say B minus A complement will be what? We said we have 8, 9, 10. That means B minus A complement will be 1, 2, 3, 2, 7. It will pass 7. That's 1, 2, 3, 4, 5, 6, 7. I have 8 here, I won't write it. I have 9 here, I won't write it. And I have 10 here, I won't write it. Now, note something. A and B are the subset of the universal set, because everything I can find in A and anything I can find in B, I can find them in the what? In universal set. Which means if I join, they can also ask you this: what is A union B or complement? We can pause the video and solve that. A union B or complement. A union B or complement. The first thing you do is that what? Join A and B. So if you join A and B, what do we have? We have 3, 4, 5, 6, 7. Oh, we have written 5, 6, 7 before. So I'll start with 8, 9, 10. Now the complement now would be what? The element I can find in the universal set, but not in what? In this particular set. And that's what? 1, 2. Thank you. Now you get it, you get it. Now if you have any question, please don't hesitate to put it under my comment section, and I promise I'm going to solve it before I release the next video. If you have any topic that is giving you problem under maths or probably physics, you can drop it under the comment section. Just drop the topic, then I'm going to solve it. Don't forget to add your name in it, so when I want to post the video, I'm going to tag you. Thank you very much. Watch out for solving set theory part 2 Venn diagram. You're going to love it. This Venn diagram, let me just give you a cheat. This is what I want to give you the intro. The Venn diagram is the what? Representation of set with brackets. The universal set is the universal set is what? Brackets. I say it's the brackets, it's the rectangle. While the particular set is the sphere that we can find in the what? In the what? In the rectangle. Which means this one here is the universal set, or sometimes you can write it as what? This total set. While this can be set A, this can be set B. If set A and set B have anything in common, they come together and form this. If they don't have anything in common, they keep separating. Now, if there are some elements that is in universal set but not in A and B, they will keep walking around in the what? In the bracket, but they will not enter into the sphere. Into the sphere. Watch out for it. I'll be posting it next. Thank you.